Alright, so practice test number one. I would suggest as we do these practice tests, if you didn't already do it on this one, use the practice test experience to build your note card. So it needs to be a standard 3x5 note card. You know you have the right size if it fits in your calculator cover and can live there. But anything you had to look up while you do this sheet, you can't look up while you do the test. So when you have to look it up and you're in the process of looking it up, whoop, just transfer that knowledge over onto your card. So we're off number one. I put these problems on the same page, even though one of them was from 5.1, one of them's from like 5.4, and the other ones are from like 5.7, because they're a little bit similar processes and they have a little bit similar answers. So if you see one answer here that's out of whack, you know that you're out of whack. These are all in the 1300 to 1400 range. So what I have in mind for A is that you do the antiderivative and then you plug in. And when you plug in generally first the top number, then you plug in the bottom number. The bottom number you're grateful to me because 0 is your friend, and then you do what with those results? You subtract. Anybody have an answer in the 1300 to 1400 range? It is 1365.3 repeating. Then, for rectangles, what you have to do is split this up into 4 equal sized pieces. Each piece would be a length of 4. And your magic numbers of where you would cut these would be at 0, 4, 8, 12, and 16. That's where your cuts happen. Those aren't for rectangles, though, the numbers you plug into any kind of formula to get some y's. The midpoints, if you're 0, 4, 8, 12, and 16, where are your midpoints? 2, 6, 10, 14. 2, 6, 10, and 14 are numbers that lead you on a path to how tall the rectangle is. How do you take 2, 6, 10, 14 and know how high the rectangle would be? In this case, you're gonna square. Why? That's what the formula says. So if this formula said x cubed, you'd cube. If the formula says something else, you'd do something else. Whatever the formula says, you do to those numbers. So what we need to do is take 2, 6, 10, and 14, square them all, add them all up, and when you're done, multiply by 4 because they were each 4 wide. Anybody have a slightly different 13 to 1400 kind of answer on that game?
1344.
1344 is a win. Plan C, trapezoid rule is more fresh, so you might be better at this. Trapezoid rule, out in front of parentheses, you would stick who over who, 4 over 2, and then you'd have to work off of the 2, 6, 10, 14 set of numbers, or work off the 0, 4, 8, 12, 16 set of numbers. The 0 to 16 set of numbers, and do what to them? Square them. And then we're going to add them all up, but with a twist on the trapezoid rule. What's the trapezoid rule make you do? The sum of the numbers. Most of the numbers.
Multiply by 4.
No.
Or multiply by 2.
Multiply by 2 for who?
Like anything in the middle.
Anything in the middle, just not first and last. Anybody on that one have a 13, 1400 kind of answer? It is 1408. And then Simpson's is a minor change. Instead of 4 over 2, 4 over 3. And instead of double counting everybody through the middle, would 2s and 4s. So from the outside in, the first and last get counted how? Once. Stepping in toward the center, the next level of peeling the onion counts 4s. And then the central item, 2. You're going to twin an earlier answer if you're right. It's the 1365.3 with the bar on it, perfection match. Simpson's rule is not always the best, but it's often the best. And if anybody were going to twin something, I would guess that it's that. Generally speaking, the higher the power, the more variance you get. The lower the power, the more it matches. Remember, Simpson was based on a thing called parabolic arcs. Parabolic arcs are U-shaped. X squared is also U-shaped. So when you do X squared stuff, which is U-shaped, with parabolic arcs that are U-shaped, that's going to go pretty well. The other stuff, you know, again, the higher the power, the less it's going to perfectly match. But it still might. Simpson's rule is pretty good. Question about 1 to 4 strategy.
What did you get for the trapezoid?
Trapezoid was 1408. Simpson matched the part A, the 1365.3 repeated. Anybody page 1 for that 4 points?
Yeah. How do you do C?
C was 4 over 2 because it's width always over 2.
Okay.
And then in parentheses, 0 squared, 4 squared, 8 squared, 12 squared, 16 squared all added up. But double count all those middle ones. Once you square them first, then double count them.
Okay. So you said 4 squared, 8 squared, 12 squared, 16 squared. With
Yeah.
the 4, 8, 12.
Yeah, the 4, 8, 12 list gets squared for,
Okay.
yeah. Simpson uses
And then
the
it's
4, 8,
4 over
12
3.
rule. Trapezoid uses the 4, 8, 12 list, but rectangles uses the 2, 6, 10, 14.
Okay. Okay.
And the directions kind of give that away because midpoints.
Yeah.
It specifically says that to switch lists. Anything else? Page 1. Page 2, you'd again cut this into 4 pieces. So your magic numbers would be -8, then where's your next? -4, 0, 4, 8. That's your cut points. Those aren't your plug-in numbers. What do you have to do to get the plug-in numbers? Midpoints. So what are the midpoints?
-6, -2.
Yeah, 6s and 2s. Every 6 and 2 variation. So 6s and 2s. Like the rectangle question on 1, what do you have to do to the 6s and 2s numbers? Plug them in, and you're going to get temporarily a bunch of Rudy roots. And what I did off the notes from this, I made a table. I always tended to make a table on these when I did them. Although when I made my answer key, I didn't do it that way. But in modern era, I'll usually make a table. So you'll get 2 of them that are the root of 28, and 2 of them are the root of 60. And then you're working off a cylinder formula, which is pi r squared h. So that would be card worthy. I would guess a note for Simpson's rule is card worthy, the formula with h over 3 from the notes. I think the trapezoid h over 2 formula might be card worthy. Here the formula pi r squared h might be card worthy. But we're going to square all those roots so the roots go away. You're going to add them all up. You're going to throw a pi on there. And then you also have to remember to multiply by, in this case, 4, I think someone whispered, because that's how wide, they're spaced 4 wide across the board. I left a pi on mine and I'm in the 700s range. Anybody get 700s of pies? Maybe. If you're like 2100,
703.9.
it should just be flat out 704.
I got 703.9996.
Yeah. Did you try to like reverse engineer it from your answer?
Yeah, I
yeah.
have
It's because you
written down
it's because you
11.
rounded and you lost them.
Yeah.
704 pi. That's the money answer there. Anybody 2?
Is this 24?
704. 704 pi. Anybody need more there? 3. Then we're working from combination of creation and cards. I did 3 by creation. I just plugged in 1, 2, 3, 4 and added up the results that I got. But if you wanted to use a card-worthy formula, we have a formula that does K's counting, and then you could just divide by 2. Either way, it's a single-digit number.
5.
It is 5. 4 you're going to have to use by doing your trig chart, keeping in mind probably for more people degrees are more comfortable. Pi is the same as
180.
180, which is over here. Then 2 pi is, which is over here. They share an axis, so they're going to share the same answer every time. What is the sine answer of everything that's on an x-axis kind of location?
0.
It is 0. So what you're having happen on 4 is 0 plus 0 plus 0 plus 0, and you get 0. Sometimes I can make that go 1 plus negative 1 plus 1 plus negative 1, which could end up being 0, or could end up being 1, or could end up being negative 1. It depends on which axis I pick, which trig word I pick, and whether I pick an even or odd amount of stuff, but those tend to be zeros, ones, or negative ones. 5, you'd have to plug in to create. We got, this, and that. We take turns with signs. You end up on 5 with the famous Pittsburgh baseball number.
21.
It is 21. Roberto Clemente. If you don't know that, you should be forced to move out of Pittsburgh. 6, we have a formula for K's, and I made the upper limit 50 for that one, smart alecky teenager one year who was like, I'm just going to plug them in and add them up. I'm not going to write the formulas down. It's like, fine, 50. But this is a card-worthy formula. The sigma thing with K's is card-worthy. Over 1,000? 1275 is right. Then I went to 60 with K squared, which is a card-worthy formula for K squared. It's like a 5-digit number.
73.
It is 73,810. 8 is on the card. Cube formula, it's a 6-digit number. Starts with a 6.
672.
It is 672, 400. And then 9 is like a combination of those. You would do the K squared formula with 20, and once you did, multiply by 2. You'd do the K formula with 20, multiply that by 5. Because it's subtracting, subtract the results, just work it on out, and it's like 4,000 something. Everybody 4,000 something. We'll just let that one twist in the wind. Anybody need some help up to 9?
So wait, how did you say you would do that?
So I would do the K squared formula like number 7
Yeah.
using 20.
Yeah.
And once you do that, then times that 2. In a minute, because of the minus, we'll subtract. But first I'd have to do the K's formula like I did number 6. But once I do the K's formula like I did in number 6, I would take that piece times 5. You with that?
Yeah.
And then stuff minus stuff. If you get it into the 4,000s, you're probably. Because what's the chances you get in the 4,000s and be wrong? Roughly 999 out of 1,000, I guess. Anything up to 9? 10, we go creation style. So you either had the intuition or you didn't. I can't really tell you if your answer is the answer because it isn't the answer. It could be an answer. So I'll just tell you what I did. It's 10. I did my K's from 1 to 5. You don't have to, but I did. You definitely will have 6 times K. It's unavoidable that you have 6 times K in your math. I have that. You should all have that if you're right. And then I threw on a -1 in parentheses to a K plus 1. That is a correct answer. 11, any correct answer would have 2 going to a power. But how you do it is kind of up to you and me and us individually making choices. I did 2 to a power of K, and then I ran my K's from 3 to 6. 12, I ran my K's from 2 to 6 because I looked at the top first, because that's what a normal person probably would do. And then I had K over K plus 1. But I wouldn't criticize you if you looked at the bottom first and ran your K's from 3 to 7. And then had K minus 1 on top of K. But if you always look at the bottom first, I don't know, you're living your life upside down, but that's okay. Anything on those 3? If you have an alternate answer, you could yell it out and I could tell you if it's acceptable other than the ones that I read, because there's an infinite number of answers. Bratty people like to do funny things for those, like run their Ks from 1,000 to 1,004 or something and make me figure out if they did the right thing.
I'm just putting this in. This
Yeah, it's a combination of funny and annoying. It depends on the day, I guess. You can do all sorts of weird stuff with those. 13, you need to do an integral from 3x squared, an integral of 3x squared plus 5x. So when we first did this lesson, you were doing those with formulas. You could still do that. I think for simplicity's sake, the easiest way to do the integral of that 3x squared plus 5x is do the antiderivative and then the plugins, plug in 6, plug in 0, subtract, get the results. But if you liked using those formulas, you could. We had formulas, again, for our x squareds, x's, and c's. Well, area part of this would get you one of the points. The area is in the 300s. Getting 300s area. It is 306. Then how do you do an extra step to get the average value once you got the area? Divide by 6, because it's 6 wide. If it went from like 1 to 6, you'd be dividing by 5, because it's 5 wide. 51 is therefore the answer. Something to tune back up on that. 14. How would you start 14? Algebra instincts.
Factor.
Factor. How's it factor?
X plus 4, x minus 3.
Agreed. So what does that factoring tell us?
Touches it, negative 4 positive.
Agreed. So we've got a negative 4 touch point. We have a positive 3 touch point. We know from life and algebra experiences, hopefully, that x squared stuff is always in the shape of a U. We have to figure out whether it's right side up or upside down, and it's right side up. Two ways we could know it's right side up. One of them which gives us a little bit of a specific detail for the graph. One that's not as specific, but could get by with it. How do you know it's right side up? It's positive x squared. How could you get a specific, another detail here though that's even better than that? Plug in 0. If you plug in 0, who comes out? Negative 12. What does that tell us about this? Say again?
It's where it touches the y-axis.
It's where it touches the y-axis. So this touch point would be down 12. We get something like that. Then we only care about the stuff from 0 to 6. So we care about this. And we care about that. So there's 1 point for you. Graph it. Check. Anybody bothered by the graph? Then what we're going to do, to figure out this zone, we're going to do the integral from 0 to 3 of x squared plus x plus 12.
Wouldn't it be minus 12?
Minus 12, good call. So we're going to do the antiderivative, the integral of that. You could use the formulas that I said you could write down, but I will never use those again. Even when we learned that lesson, I said, like, here's some stuff that's going to get used for a day. You probably don't want these long term. I would do this integral by antiderivatives and plugins. What type of answer should I get? It is negative for sure. It's just a question of negative how much. Anybody have a negative opinion on that? It's not a whole number, but it's not ridiculous in its decimalness. Not yet. Okay, I'll tell you it's negative in the 20s. So if you get something negative,
Which number would you plug in?
so we'll go antiderivative first,
Yeah.
and then you're gonna plug in 3, you're gonna plug in 0, and
Okay.
you're gonna subtract those results, the 3's result minus the 0's result.
Okay.
What would you do for this one?
The thing from 3 to 6.
Integral from 3 to 6.
Of the same.
Of the same thing, which would get you the same antiderivative. Your plug-in though would go from 3 to 6, which means you only have to plug in 6 because you already plugged in 3. It didn't
Yeah.
change in the last 2 minutes. So 6's result, which is new, minus 3's result, which you could recycle from a second ago. Since nobody got that one, I'm presuming nobody got that one. But I'll tell you, this was in the negative 20s. This one was in the positive 40s. Neither of them is a whole number, but neither of them have a decimal that's like an O.
Is it negative 22.5?
It is. Then we're ready to give answers. Area technically always has to be positive. So we're going to want to add those together, both being turned into positive numbers, and that's the area result. Integrate it means to put them together, allowing them to be what they want to be, which is a negative versus a positive, and we could get that way. Something else you could do either as a check or as an alternative. You could also have done at the beginning the integral of 0 to 6 of that same formula, which would give you the same antiderivative, and you could work from 0 to 6. That's a way that you could check if this negative plus this positive makes that result in agreement, keeping the positives as positive and the negatives as negative, then you did a lot of good right stuff. Then it's going to speed up again. Anything on 14?
Did you ever say what the other?
I didn't. No, I committed to negative
Is the
22.5.
positive part 40.5?
Positive is 40.5. So the adding them up as they are
63. Well, as they are, I don't know.
is,
The area. would be
the area will be 63, yes. And then the integrated
18.
is 18. Then we're doing antiderivatives and plus C's for a lot of problems. I'll just rattle these off and then you tell me if you need some guidance as to how. Powers rise by 1, and then the numbers in front, we're going to divide by that new power. 15 is 1/7 x to the 7th plus 4/5 x to the 5/4. 16, you're not really able to do it. You just have to have written it down from page 317 or something. One of the videos said, like, put this on your card. Like, there it is. Just put it on your card. It's a free point. If you don't put it on your card, there's like little to no chance you'd figure it out. There's a whole process of how that's done. I probably didn't even do the process when you guys watched that video from being at home because no one cares. We just need that answer. It's going to be theta over 2 plus sine 2 theta over 4. 17, I separated into 2 fractions, then attacked them. So 1/5 x to the 5 plus 1/4 x to the 4. 18, trig antiderivatives are probably card worthy. This will be -8 secant x. 19 is 3x squared plus 8x. Everybody gets a plus c. Or you can do what I did and put one big, nice, tall c to cover the whole zone. Question 19.
What was 19?
19 was 3x squared plus 8x plus c.
What was 18?
18 was -8 secant x. Anything to 19? 20, just keep going. 20 is -1/6 cosine 6 theta. 21 is 3/4 x to the 4 plus 4/5 x to the 5 plus 5/6 x to the 6. 22 is 1/4 x to the 4 plus 3/5 x to the 5/3. 23 is 9/11 x to the 11/9. 24, you want to rewrite with negative powers, and then be careful when negative powers rise. It can sometimes deceive people when you're in negative territory and it's counting inside out, sort of. It's -3x to the -2 plus 8/3 x to the negative 3. 25 is a nice long one. It's 3/2 x to the 4, if you reduced your fraction a little bit, plus 5/3 x to the 3, plus 3x to the 2, plus 8x, and those all had a plus c or a big plus c. 26, you do the antiderivative and plug in. 27, you do the antiderivative and plug in. And in a weird detail of total just accidental coincidence, they're almost twins. 26 is 160 on top of 3 if you like fractions. 27 is 161 on top of 3 if you like fractions. If you like decimals, 26 is 53.3 that repeats, and 27 is 53.6 that repeats. I could probably only do that again if I tried, and it would be hard, and I don't want to. But to make two answers that were almost twinsies like that, not likely. Anything to 27 I can do. Then things probably slow down. So this was, I think, the hardest lesson we had. I'll give you the final answer and then we'll rewind back through. But you have to, if you want to process to this, you have to pick a u. For 28, u would be 3x squared plus 5 because it's under a root. If something's in parentheses, that's probably your u. If you see trig words, take the trig word that went to the power. That's how you pick your u. Then you find a du by doing the derivative, and that rarely is a match. And you almost always have to do things like put an 8 into a problem and a 1/8 into the answer, or put a 6 in here and a 1/6 there. There's almost always like a trade-off because the du is a mess. You'd rewrite the problem that has u's and du's. You would do the antiderivative while it had u's and du's. Then you have to switch some stuff back. But 28 grand total, if you do all that right, would have a 2 in front, and then there would be in parentheses a 3x squared plus 5 that's been the u, and that's in parentheses 2 the half. If you don't have the 2 in front, that 2 happened as you did the antiderivative is where that happened. 29, the problem is going to need a 5, so the answer is going to need a 1/5. The answer is also going to get a 1/9 created when you do the antiderivative, but grand total is 1/45, and it's sine of 5x, and there's a 9 exponent involved. Either write sine 5x in parentheses to a 9, or write it how I wrote the problem with the 8. You could write it sine little 9 5x. This whole page, FYI, has plus c to it. 30, the problem needs a 10 inserted when you're like squaring up your du. The answer needs a 1/10. Grand total is negative 1/10 cosine, same parentheses as before. If you're feeling a little bit of chain rule flashback vibes, it's because this is the chain rule, it's backward. So if you remember back to the chain rule, when there were parentheses in the problem, they were still there in the answer. And likewise for this, if there's parentheses in these problems, they still need to be there in the answer. 31, slightly deceptive because there are two sets of parentheses, so which one do you pick to be your u? The 1 to the 10th. The longer one that was to the 10th is your u. The du is magically the other one because I was kind to you. Grand total answer is 1/11. The set of parentheses that started with the 6 still there, but it's to the 11th. 32, you could do one of two ways. If you understand this chain rule backward substitution thing, you could just keep doing that. That's what I had in mind. But if you hate that, you could just distribute this and do it like you were doing the other pages, because I created a weak problem there and left you a sidestep. So it would be legal in my mind to sidestep that. But I did the substitution way because I was in that mode on this page. I inserted a 12, so the answer needed a 1/12. The antiderivative created a 1/2 to go with the 1/12. So my grand total is 1/24, and my set of parentheses is squared, and that's all a plus c. If you've done those pages in the book, this probably went well. If you haven't done the pages in the book, this probably didn't, because honestly, you just need to practice it. Once you get the pattern of it, they're kind of all the same and they're not bad, but until you get the pattern, they're a strain because it's like it takes like 5 steps probably. Pick a U, pick a DU, make the DU match, rewrite it with U's and DUs, do the antiderivative, swap back. I mean, it's like a 6-step plan, but it's the same steps, but if you have to do 6 things, there's a chance you get knocked off the beam. Anything of those you want me to just like do one all the way out? Needs there.
Can you do the first one?
First,
Yeah, 'cause I get the U and DU and then put them back.
so first one. So you're good with why I pick U to be 3x squared plus 5.
Yeah,
You're good with DU is the 6x dx.
yeah, it's just the top.
So when I rename this is DU.
Yeah.
This is U root.
Yeah.
Then we act like we're a couple pages back. So to do that, I would retitle that U to a negative half, because negative power on the bottom, half power per root. Is that where you went off, maybe? Then antiderivative, rise a single number from negative half to positive half. Now, always divide in front by new power, so divide by fraction, flips it, so that's 2. And then we get back to 2. 3x squared plus 5 needs to make its return, either in parentheses to the half or rooted. That's your call, how you like to write it. And then it always makes me happy to put on the plus C because I know I'm done. It brings me joy. Is that okay? Anybody else on that page want me to tackle another one or 2 or 4?
So do you always just ignore the DU when you're doing that?
You ignore the DU every bit as much as when you did the page with like 20 to 27. How did you feel about the DXs? They were just decorative. So likewise on this page, the DUs are just as decorative as those DXs have been. It's like the parsley on your plate. It's just a garnish. It doesn't do anything. It's like remnants of the days that they were doing this the long way with rectangles. It's just like the delta X was like the width of all those rectangles, and they wanted to include that in their like symbols of how they wrote this, but it didn't really do anything then, and it doesn't really do anything now. I guess it did something on page 1. We had to multiply by it, but once they introduced limits and doing them so they were so small, they were basically 0. Those DXs are basically like empty spaces now. That last page probably speeds back up because we've been here, done that. It's just the initial value problems dusted off from our antiderivative lesson. You do the antiderivative, you temporarily put a plus C as a filler, but then you're able to do algebra to figure out what that C should have been. So 33 is y equals 3x squared from doing the antiderivative plus a 2 because algebra says so when you plug numbers in. 34, you'd have to work through 2 levels. At the first level, the C is going to be a negative 206. So if you didn't see a negative 206, try to see if you can get a negative 206 figured out at level 1. But then you have to go to level 2. Grand total, when you've done an antiderivative, figured out a C, done another antiderivative and figured out another C, it's in the 900s for the C. Anybody get a 900s for the last C? It is. So grand total is 1/4 x to the 4 minus a 206x. The 206 appeared on the scene as the first C you got, and then plus a 920 is the total victory of that. Anybody need any more detail there? People in the future, hopefully they don't need details you didn't ask, but they probably have access to either me or my answer key. And